Alrighty, so I think we're starting to understand a little bit about the inverse, sine, cosine, the one-to-one functions, and why it's important to limit them. Remember, we limit our functions because we want them to be a one-to-one. That way, when we graph the inverse function, it's also a one-to-one. So when we graph our tangents look like this, and it keeps repeating this look every pi, right? Well, we are going to limit, we don't want all of it because then it's not a one-to-one function. It fails the horizontal line test. So we're going to limit ourselves between negative pi over 2 and pi over 2. So when we put our restrictions on y, we're going to go from negative pi over 2 to pi over 2. All right, so those are going to be my limits. So please notice this says less than or equal to. That needs to be changed. It's not less than or equal to. It's just less than, because when we hit negative pi over 2, tangent becomes undefined. When we hit pi over 2, tangent again becomes undefined because those are my vertical asymptotes. You can see that on the graph. These dotted lines are my vertical asymptotes. We get a 0 on the bottom of tangent right there, and we really don't want that. So we're going to graph this. Again, when we are looking between negative pi over 2 and pi over 2, we are going to be in quadrants 4 and 1. We're on the right half of my unit circle. Well, not my unit circle, our unit circle. It really belongs to all of us, doesn't it? It's all of ours. So I'm going to switch to blue ink here, and let's do finding some arctangents. Now notice again, I say without a calculator. So that lets me know again, I need to use my unit circle. But this one says do everything in degrees. No big deal. No big deal. Tangent, though, is kind of a pain because remember, tangent, arctangent is sine over cosine, or when we're looking at our points, it's y over x, or another way of saying it would be y over 1 times 1 over x. And that's going to help us get our negative values, or our arctangent values. So we want to find the arctangent of negative 1. What I know about a negative 1, so to return, to have a negative tangent value, we know either x or y has to be negative, only one of them, and they have to be the same. Well, for one of them to be negative and one of them needs to be positive, in our restricted values, we need to be down here in quadrant 4. And where are my values the same but opposite signs? That's going to be right here at radical 2 over 2 and negative radical 2 over 2. And that happens at my second line of the group, which you'll remember we count 30, 45, 60, 90. So this is going to be a negative 45 degrees because we are going clockwise. To get negative 1, when I look at it and I do y over 1 times 1 over x, we would do negative radical 2 over 2 times 2 over radical 2. Let me rewrite that. And then we'll notice everything crosses out, and that leaves me with negative 1. That's how I got it. Because remember, my values of tangent are either going to be 1, negative 1, positive negative 1, positive negative radical 3, or positive negative radical 3 over 3. And those are my values of tangent. It depends on where you find them. Speaking of which, so again, I want it in degrees, and I want that without a calculator. That means we need to use that unit circle. And we are talking quadrant 1 and quadrant 4 because of how we limited our graph. Alrighty, again, tangent is going to be y over 1 times 1 over x. I want it negative. That means we need to be in the fourth quadrant, 1 positive, 1 negative. I'm going to want to take the square root function and put it on top. That's actually going to be this, the first line right here. This is going to be our point radical 3 over 2 and negative 1/2. How do I know it's this point? Well, if you take your y value, negative 1/2, and you multiply it by the reciprocal of x, you're going to notice the 2's cross out. That leaves me with negative 1 over radical 3. Rationalize that to get negative radical 3 over 3, and that's what I want. It's the first line below the x-axis, and that's at negative 30 degrees. Boom. Why don't we do this one in class next time we meet? And we'll talk about how to find it, because tangent can be a little tricky. We've only taken 5 minutes. Why don't we go through and do an example, some of these in example 4. Now, when we're looking at these, again, they are saying without a calculator. That means we want to use the unit circle. They didn't specify how they wanted me to evaluate, so I am going to use radians. So when we are looking at our unit circle, where is the sign when we write our point? So the first line up has a sine value of 1/2, and the cosine value is negative 3 radical 2, and that's at pi over 6. So we're going to find the sine of pi over 6. Well, so we look back at this. The sine of pi over 6 is 1/2. So if you have the sine of your arcsine, your sine of your arccosine, your tangent of your arccotangent, it's always whatever that value is. That makes it nice and easy. So on this one, what we are going to do is it's going to be very similar to what we did, but remember on these ones you always have, we switched our arcsine and our sine. What that means is we have to pay attention to our domains, our restricted values. So the sine of 135, the sine of 135 is right here. Because it's 180 minus 45, so that gives me negative radical 2 over 2 and radical 2 over 2. Now when we do the arcsine of radical 2 over 2, we're not going to be in quadrant 2. We're not going to be in quadrant 2. We either need to be in quadrant 1 or we need to be in quadrant 4, because we limit our sine to these two quadrants. Well, so where is my sine value radical 2 over 2? And that's this line right there, because this gives me radical 2 over 2, radical 2 over 2, and that is at 45 degrees. Why is it not 135? Because I had to remember my arcsine is in quadrants 4 and 1 only. 4 and 1 only for my arcsine. Okay, so let's find the tangent of cosine, the inverse cosine of 0. So let's start inside the parentheses. Let's find the arcsine of 0. Now remember, cosine goes from 0 to pi. Arccosine goes from 0 to pi. So we have an x value of 0 right there, the 0.01, and that is going to be at pi over 2. So we want to find the tangent of pi over 2. Well, if you remember, when we found our arctangents, we're limited between negative pi over 2 and pi over 2, but y cannot be either of those values because that's where tangent is undefined. So we are undefined for every arctangent or tangent value. we're undefined for every tangent value when it's half of pi. All right, let's, once again, unit circle. See how important that unit circle is? So we're going to find the sine of 5 pi over 3. Over 3 are the ones closest to the y-axis. 5 pi over 3. Wait. The sine of 5 pi over 3. This would be 3 pi over 3. I am drawing, hold on a minute, I'm going to pause, I'm drawing a blank. All right, sorry about that. I just had a mini, meltdown. So the sine of 5 pi over 3. Well, 5 pi over 3 is this guy right here. So 5 pi over 3. All right, so when for the reflection of this, so this is going to be we're looking at this point right here, which is radical 3 over 2 and negative 1/2. So the sine of 5 pi over 3 is going to be negative 1/2. And we want to find the arccosine of that negative 1/2. Well, arccosine goes from 0 to pi. So we got to watch out for that. So where are we negative 1/2? Well, negative 1/2 on the x-axis is this point right here, which is negative 1/2 radical 3 over 2. And we have a reference angle of pi over 6. So I would do pi minus pi over 6, which we've already established as 5 pi over 6 in a previous example. Boom. Not so bad. Now I want to do examples E and F in class because they're going to require us to go back and remember stuff about sine, cosine, or tangent from the very first time that we got together. So let's do E and F in class, and I will see you in class for these two. It'll be a hoot, I promise.